For the last few weeks, I've been working on this game that combines a roguelike deck builder and an action roguelike. You can move and dash around as normal, but the twist is anytime you attack, it instead slows down time and you play a card. Each card is a spell that you aim and cast in a direction using the crank to aim. This might seem like a strange genre mashup, but I got a pretty good reason for this. If you noticed, I'm developing the game for this little device called the Playdate. I wanted to make a fast-paced game that had sort of twin stick-like controls because recently I've been playing a lot of games in that genre that I've been having a lot of fun with and wanted to replicate. The problem, however, was that I was already working on a game, just a regular deck building game that played very similarly to Slay the Spire. I've already put a lot of work into the game. There were some combat mechanics, being able to target and attack enemies, a turn-based system where the enemy attacked, some polished animations, a hold card inspection system, some localization, along with some level progressions with animations and everything. However, I spent all this time polishing up the game loop when really I should have been prototyping more. Despite putting all this work into the game, I had a sudden realization when I was playtesting, and that realization was that it kinda sucked. I started thinking about what would make it fun from the state and came to the conclusion that there was a ton of work that needed to be done. Mainly, a bunch of additional card mechanics that could interact and synergize with each other, which I felt like would be pretty hard to program. As mentioned before, I've been playing a bunch of fast-paced action combat games recently, like Tiny Rogues, Neophyte, and also a lot of Minecraft Dungeons with my wife. I felt like programming combat interactions would be way easier than card interactions, and also the realization that my game in its current state wasn't that fun gave me the push to try to go for a hard pivot. However, I didn't really want to throw away all the work I've already done, so I wasn't really sure what to do. But then I got some inspiration for a game I recently played called Heck Deck. This game was sort of a bullet hell game, but the bullets were all cards, and time only progressed when you moved. This showed me that it was possible to combine some sort of deck building element with action elements, and that was enough to convince me to jump on the idea. I started an entirely new project, and the first step was rewriting the scene management system. I had to scrap a few things from the previous project, but most things, like the transition animation for example, I could port directly over. I then got straight to work on the character controller. To help alleviate some of the weird jittery movement on the diagonals, I added some camera smoothing using a lerp function to even things out. Then I started work on adding a simple slime enemy and implemented basic collisions. My last game was a Vampire Survivors-like game called Core Fault that I made with my friend Dave. But on that project I ran into a lot of issues regarding performance. I was coding in Lua, which is a relatively slower language, and the Playdate CPU isn't super powerful, so I knew I had to change my approach from the ground up. Luckily, I learned a lot about the bottlenecks in my code since then. The first one was rendering, specifically with sprites. In the Playdate SDK, there's a built-in graphics system called sprites that are really convenient to use, and also optimize drawing by not updating the screen when the image doesn't change. I was originally under the impression that this was the most efficient way to draw things, but I started to think about what happens when the image frequently changes, like the player and all the enemies moving around and animating. In that case, the convenience of sprites just adds a ton of overhead. So I found out that drawing images to the screen directly with the draw method is much faster than using a sprite, which in hindsight should have been kind of obvious. However, by drawing manually, I lose out on a benefit with sprites, which is built-in collision detection. The solution to that was, of course, just to roll my own collision detection, which I was worried about doing, but ended up being more straightforward than it sounds. I just went with the naive approach, which is looping through the list of enemies and checking if they overlap with the player, using the simple function to check overlapping rectangles. Having to iterate over the list of enemies each frame might seem slow, but I already have to go through the list anyways to move the enemies, so by doing it in the same loop, it's not too bad. Sprites are also objects, so it seemed natural in the past to use mainly object-oriented programming to create things like an enemy class or a player class. But from testing, I found that method calls and accessing properties are a little slower than regular function calls and accessing local variables. So I ditched the object-oriented programming and went with the entirely data-oriented approach, which stored data about each aspect of the enemy, like its position and health, separately into their own arrays. I don't want to get too in the weeds about the technical aspects of this, but basically the end result was being able to manage and draw about 150 enemies at once, and with the same conditions using sprites, I can only manage about 50 enemies. This is great because I felt like I really only needed about 30 enemies on screen at once for the game, so there would be plenty of overhead for audio, particle effects, etc. Next step was to port over the old code that animated your hand of cards, which I did on a live stream. Included in that was a card playing animation. I tested out what combat could look like by implementing a simple fireball spell. To get that working, I created a separate projectile drawing and collision system, and I started to get a feel for if this was the right direction. One thing I noticed was that it was hard to leave my shots with where the enemies were moving, so instead of freezing time, I made it slow down time instead. To do that, I finally got around to implementing delta time for once. All my previous games were entirely frame rate dependent, which I knew I should have changed at some point, but was too lazy. I found out that it's actually not that hard though. You can calculate delta time with this little bit of code, and then just pass that value around to whatever needs it. I added a dash because, you always have to have a dash, and went back and switched up all the player and slime art. I'm still not really settled on the art, so I'll probably continue and change and tweak the style, and I'm open to suggestions. I knew I really should have been prototyping more, but I couldn't resist adding at least a little bit of polish, so first I added an enemy damage flash, and then I added some death particles for when the enemy dies. The particles are pre-rendered into an image table for performance. I did some experiments on what a real-time particle system would perform like, but it's really performance intensive and doesn't look that good, so I'll be sticking with pre-rendered particles for the foreseeable future. The dash looked a little bland, so I took some notes for how Hyper Light Drifter handled their dash animation. It looks like it leaves a trail of the player sprite that fades over time, so I created an animation that fades out the player sprite, and every frame of the player's dash, I drew that animation at the location of the player. This gives an illusion of a fading trail effect, which I think looks pretty good. The player needed some polish for the health system as well, so I added a heart UI, some screen shake, and also the player flash on hit. At this point, I was ready to go back to prototyping game mechanics, so I got to work on the mana and card draw systems. My initial idea for this was that your mana and your card draw would be on a timer, and so you would have to strategically time when you attack and when you evade. I went through multiple iterations on the UI to make sure it didn't take up too much space on the limited screen, and I eventually settled on the icon itself filling up. I hooked up all the systems together and went ahead and started playtesting a bit. However, I discovered that this current iteration wasn't very fun, which was strange because I found that the version without the mana and the card draw was pretty satisfying to play. I eventually thought that maybe it had something to do with the natural attack speed of this type of gameplay and the strength of the attack. You see, when you're playing a game where you can attack continuously, it's fine to have a weaker attack that slowly chunks down the enemy health since your attack speed is so high and non-committal. However, with this game, there's a bunch of friction with attacking since you not only have to bring up the hand, you have to choose a card and spend time aiming. However, if the end of all that work is a weak projectile attack that does a tiny bit of damage, it doesn't feel that fun. One idea I had to fix this was just scrapping the hand entirely and have the player just shoot the spells directly, but I found that my hand was cramping up when I was continuously holding down the D-pad. Using the crank and the D-pad at the same time suffers from the same issue. So the only other obvious solution was to have really powerful attacks. I tried adding a strong lightning attack that does a lot of damage in a line, and I found this to be a great middle ground. Because it hits multiple enemies at once with a lot of damage, I felt that the time I spent selecting the spell and carefully aiming it to hit as many enemies as possible felt a lot more rewarding. I'm thinking that this is generally the direction I want to try taking it, but of course I need to add several new spells to really test it out. You can also try the current build of the game and also see the source code on my Patreon. Anyways, that's all for now and see you next time.